didn't it make it blank? Okay. Okay, so okay, so we had this, correct? This is where we all were. We rewrote that as u to the half. So we will take that times u prime. Before we do that, let's get the derivative of u, or of d, excuse me. So here is our derivative of d. Follow me so far? Okay. U, we are saying, is x squared plus sine squared x. Derivative of u is 2x plus, we have to find the derivative of this. This part and only this part is where our w comes into play. So this part we're going to rewrite as w squared.
Why w squared?
Because this is it, yeah. So w is sine of x. So derivative of w squared is 2w, correct? What's the derivative of w? So I'm going to take this portion and this portion times each other because that's how I find the derivative of, if it was just sine squared x all by itself, that's how you would find the derivative. So that's why I'm multiplying just those parts together. And so I have 2x plus 2, w is sine x, w prime is cosine x. This right here represents u prime. So I'm going to take this times this now.
And the sine is just because that's what w actually is.
Right.
Okay.
Right. So that times 2x plus 2. Yes? No, because the derivative of w is just for the w part. When we multiply the derivative of u times the whole thing, it's because that whole back part was u. This part right here is the only w part. This part does not have w in it. This part all had u in it. So that's why we multiplied the whole thing by our u prime. Usually when you guys are doing w, you do multiply it by the whole part. But this had a little trick in there that didn't have a need for w. And then what do we multiply all of this times? X prime, which happened to be 2 again. Yep, you can take the 2 off the bottom and end up with 2x plus 2 sine x cosine x over x squared plus sine squared x to the half. How about we try some that actually get us some numerical values? A little bit more fun than these distance ones.
We should just do simple
For an hour or so?
for
Okay.
a final.
Oh. All right, so number 15. The radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rate of change of the area when r equals 6. So read number 15 and put down what you know. What do we know? And what do we want to know? So, what do we know? What is the rate of what? Radius. So we know. Very good. R prime is what? Do what? 3 centimeters per minute. Okay. What else do we know? Okay. Radius is 6. What else do we know? Or what do we want to know, I guess? Of what? Ooh, so we want to know the area derivative. So you first have to know what's the formula for area of a circle. Okay. So area equals pi r squared. Questions on that? Okay. Yes, dear. Okay. We use r prime because when we are dealing with a word problem, it's having 3 letters in it now. It's dealing with the area, it's dealing with the radius, and it's also dealing with time. R prime is dealing with time. It's the derivative of our radius in comparison to time. The derivative of area is the derivative of area with respect to time.
So it's written as r prime instead of
dr over dt. Yeah. Great question. Any others? Okay. So we want to find the derivative of our area. Do that. Everybody find the derivative of the area equation up there. Pi is 3.14, if that helps. Chad Beck. Wow.
What's on every single paper he has?
yes.
Like in PE, he'll write it on his paper.
Gotta stay up on it. Gotta practice. Okay, what's our derivative here? That? Oh, 2 pi r. Do you agree? Move your exponent in front. Drop your exponent by 1. The derivative of area of a circle is the circumference. I wonder if there's a correlation there. All right. Is this done? Is this side done? Why not? What do we need? Not x prime, but
R prime.
there we go.
Yeah.
Questions? So let's plug in things that we know. R prime is 3, okay? And what is the derivative of our area when r is exactly 6? 36 pi? So our area is changing at 36 pi. Let's label this. Since it's area, it's going to be centimeters squared per second. And we could get that. This 6 was in centimeters, correct? This 3 was in centimeters per, not minute. Not second, I mean. Minute. Is centimeter times centimeter, centimeter squared? Questions?
Is that what?
For part B? For part B, you do the same thing. Yeah, we're done. That's our answer for part A. Here's part A. So let's do part B. Part B changes it, and our radius is 24 centimeters.
How'd you get
6 centimeters times 3 centimeters is, yes. We're going to try to put units on things. It will help you in physics, hopefully. It's what, sweetie? 144 pi? Thank you, ma'am. Questions? So instead of plugging 6 in for R, we're going to plug 24 in for R. Enjoy your lunch.